The Big Bang theory is the predominant explanation for the universe's inception. It posits that everything we witness today originated from an extremely tiny, hot, and dense point. Prevailing scientific thought suggests that prior to the Big Bang there existed no space, time, or universe, essentially a state of nothingness. However, this raises a pivotal question. If the universe emerged from nothing, how did this nothing come into being? This concept challenges the notion that nothing can give rise to something. Today's video delves into this profound query. Who or what was behind the creation of this nothing from which the universe formed? The Toba eruption, with a volume of 2,800 cubic kilometers, stands out as one of the most powerful supervolcanic events in Earth's history. Comparing its scale to other volcanic eruptions, such as Yellowstone's Huckleberry Ridge and Lava Creek, Mount St. Helens, and even more recent events, underscores the magnitude of Toba's impact. The eruption's far-reaching consequences are evident in the pyroclastic flows that covered over 20,000 square kilometers and the ash deposits found as far as Central Asia and the Middle East. In South Africa, scientists found signs of humans living near a volcano called Toba a long time ago. They discovered bits of volcanic glass from Toba in places about 9,000 kilometers away from where the volcano erupted. This shows how powerful Toba's explosion was and how far its effects reached. Some scientists think that when Toba erupted, it released a lot of sulfur, causing a volcanic winter. This might have led to a time when only about 10,000 people survived. Even though Toba erupted a long time ago, scientists still worry about it. Researchers from places like Switzerland and China studied Toba to see if they could tell when it might erupt again. They found that before Toba's big explosions, there weren't any clear signs on the surface. It seems the magma inside the volcano slowly got hotter over time, and that's what caused the huge eruptions. This means that supervolcanoes like Toba might not give us warning signs before they explode again. It makes them dangerous and hard to predict. Understanding these huge volcanoes is really important because it helps us know how risky they are. But it's tricky because they might not show any signs before erupting. It's a big challenge for scientists to figure out how to be ready for such big disasters. On a different note, scientists also think about how our universe began. They imagine a time before the Big Bang when everything was tiny particles like quarks. They believe that a very short time after the Big Bang, around 1/1000th of a second, atoms started forming. Before that, there wasn't any material stuff like atoms in the universe. But the earliest moments after the Big Bang are hard to study because we can't recreate those conditions now. Scientists have a good idea of how atoms formed soon after the Big Bang, but the very, very early times are tough to understand. They call that time the Grand Unified Epoch. It's like a mystery because we can't make those same conditions again to study them properly. Scientists are careful when talking about it because it's mostly based on ideas and theories rather than things they can see or recreate. In the past, there were equal amounts of regular matter and its opposite, antimatter. But when they met, they cancelled each other out and released a lot of energy. It was a super quick time when particles appeared and vanished constantly, like a mix of something and nothing that lasted just a moment. Scientists are curious. How did these particles come to be? Before the Big Bang, there was nothing. But a theory called quantum theory suggests that even empty space has activity creating bursts of energy. These bursts make short-lived particles unseen but proven in Earth experiments, seemingly making something from nothing. But this raises more questions. If energy made matter, where did space and time come from? Scientists look way back to the Planck epoch, a super early time after the Big Bang with different rules. Quantum mechanics instead of regular physics. Here, space and time were full of tiny energy changes. Understanding the Planck epoch means merging two big ideas, general relativity and quantum mechanics, forming the theory of quantum gravity. We struggle to fully grasp quantum gravity because the events involved are nearly impossible to replicate and study. It seems our experience of space and time is how we perceive incredibly small-scale quantum actions. The processes during the Planck epoch challenge our current understanding of physics, leaving the question of their origin unanswered. Some scientists are trying to figure out what happened before the Big Bang, the start of our universe. Even though things were a bit wild back then, some scientists believe they can explain a few parts of it. But many agree that something must have existed before the Big Bang to kickstart everything. There are a bunch of theories about this. Some folks think there might be a bunch of universes all happening at the same time, but that doesn't really explain how each universe begins. Another idea is the cyclical model. where one universe ends and a new one begins in a never-ending cycle. Now, there's this concept called the Big Freeze theory, which talks about the end of our universe being all empty, just like it was before the Big Bang. A physicist named Roger Penrose has a theory called conformal cyclic cosmology. He suggests that our universe's end, where there's no stuff left, might have caused all the stuff we see around us today. Penrose's idea is debated among scientists, but some find it more believable because our current science struggles to explain how the universe started. He thinks our universe didn't just pop out of nowhere, but might have come from a past universe that finished. Penrose is a big deal in physics and cosmology, winning awards for his work. His theory challenges what Einstein said about the universe existing in many dimensions at once. Instead, Penrose says the universe goes through different phases in a cycle. In his studies, Penrose found interesting circular patterns in the oldest image we have of the universe after the Big Bang, called the cosmic microwave background, CMB. He thinks the Big Bang that created our universe came from the last moments of a previous universe, filled with disappearing black holes turning into photons. These photons are like the ones observed at the start of the Big Bang, suggesting that the nothingness at the end of the old universe might be similar in some way to the super hot and dense state of the Big Bang that started our universe. Penrose's cosmic conformal theory is based on his deep look at the CMB, which is a crucial image showing the early moments of the universe after the Big Bang. It dates back to about 380,000 years after the Big Bang, when the universe cooled enough for the first atoms to form. Despite sounding like a long time, it's just a tiny bit in the grand 13 billion-year history of the universe. Penrose, with other scientists, looked at parts of the CMB that were overlooked before. They thought these odd things might be from really big black holes that vanished before our universe began. These black holes had so much power that they might have left a mark that stayed even after the Big Bang. The team guessed that these weird things could show leftovers from when these huge black holes crashed into each other in an old universe. When this happened, it made really strong ripples called gravitational waves that stuck around even after everything cooled down. Penrose's idea, the cyclic conformal cosmology theory, looks into how the second law of thermodynamics affects things. This goes against what most people think, which is that information disappears when stuff goes into a black hole. Most folks believe that once stuff goes past the event horizon of a black hole, it's gone forever. But Sir Roger Penrose thinks black holes do more than just swallow things up. They turn stuff into light that can exist outside of space and time. This light can last as long as the black holes do, and might be what starts a new universe's Big Bang once our universe ends. He says that after a really long time, everything in our universe will break down into this light energy in a dead, cold, expanded universe. He calls the time from one universe's start to its end an eon. The end and start of each eon become the base for the next cycle's Big Bang. At the point between the end of one eon and the start of another, the rules of space and time don't matter, making the start of the new eon seem small to its observers. Penrose thinks the super big explosion that made our universe isn't really a big mystery. He thinks smaller versions of it happen in black holes. He checked the CMB and saw circles that looked like super red light, maybe from black holes in the old universe getting into our universe. His idea of one universe ending and a new one starting is kind of like the Big Crunch theory, where everything collapses in on itself. But there's a big difference. While the Big Crunch says the universe's spread is slowing down, observations show it's actually getting faster. The new idea challenges the Big Crunch theory, saying gravity isn't strong enough to stop the universe from expanding and collapsing entirely. Instead, Penrose's theory suggests the universe will keep growing until it breaks apart, helped by black holes releasing light, possibly starting a new universe. Penrose's theory, called conformal cyclic cosmology, makes people wonder how a cold, empty universe changes into a hot, dense one. He talks about a math idea called conformal rescaling, which changes size without changing shape. He says the link between different universes might be about their shapes in space and time, not how big they are. This means our idea of size might be tiny compared to the next universe from the Big Bang after our universe ends. The Big Crunch and Penrose's theory are similar, but the Big Crunch doesn't work because the universe isn't slowing down, it's getting faster. Stars and galaxies are moving away from us quicker, showing that gravity isn't strong enough to collapse everything. Penrose's theory says the universe will expand until it falls apart, and black holes might help make a new universe with light. Scientists are checking the sky for proof. Even though we're not sure yet, Penrose's idea is a good guess about what causes the start of a new universe after the end of an old one. Understanding these concepts can be complex, but Penrose's ideas provide intriguing perspectives on the universe's mysteries. If you enjoy exploring cosmic wonders and theories, consider subscribing to our channel for more engaging content.